Hello everyone, myself Pranjal Sharma. In today's video, we will study about the motion of an object. Basically, motion is nothing but the change of position of an object with respect to time. So, suppose an object at point A at some time t equal to t1. After some time interval t equal to t2, the object moved from point A to point B. Then we say that object is in motion. The branch of physics in which we basically study about the motion of an object is known as kinematics. In kinematics, we actually study about the motion of the object without concerning about what is the agent behind the motion. In kinematics, the question is how the object move. The question like why the object move is not discussed under kinematics. There is a different branch where we study about the agent of the motion, and in that particular branch is known as mechanics. Okay, so kinematics is the branch under which we will study about the motion of an object. So before going to understand the motion of an object, we need to learn some key ideas or key concepts through which we can easily define about the motion of an object. As I have already mentioned, motion is nothing but change of the position of an object with respect to time. So the motion means change of position. Change of position of an object with respect to time. So, to understand motion, we need to specify the position of the object. To specify the position of the object, we need a set of axes and a reference point. For convenience, we use three perpendicular axes x, y, and z, and since they are mutually perpendicular, and the intersecting point of all the three axis is considered as the origin or reference point. And this set of axes along with a clock is defined as a reference frame. So an observer always present at this point, at the reference point, and he specify the position of an object. Suppose an object is at here, so it has three distinct coordinates x, y, z. So this x, y, z this is the position of the object. Suppose the position of object A is the coordinate of A is x, y, z. Then we say the position of the object is x, y, z. Now any change of these coordinates, either x or y or z, or any two of them or all the three with respect to time, then we will say that A is in motion. That means the object is in motion. So now if the object move in any particular direction, then we will say that the object move in one dimension. And in today's lecture, we will mainly study about the motion of an object in one dimension. One dimension. That means it move either horizontally like this, or vertically like this or this. So this kind of motions are known as one-dimensional motion or rectilinear motion. So one-dimensional motions are also known as rectilinear motion. So in case of rectilinear motion, the object may have forward or like this or backward. In case of horizontal motion or upward, that means upward or downward. In case of vertical motion. So the rectilinear motion is either in the horizontal direction or in the vertical direction. So it has only two movements in every case. In case of horizontal movement, the main motions are either forward or backward. In case of vertical, it is upward or downward. Since the motion is in one dimension, that means motion is in straight line. So one dimensional motion are always in straight line. Now we will understand some other concept like path length and displacement. These two concepts are very important to understand the motion of an object. At first, we will understand the path length. Suppose an object moves along x-axis. Suppose this is the origin of the x-axis. So, in this direction, it is positive. And motion is positive. We consider the motion is positive along this direction, along the, and in this direction we consider motion is negative. Let's put some value in x-axis. Suppose 10, 20, 30, 40, 50, 60, 70. And in this way, here we put minus of 10, minus of 20, minus of 30, minus of 40, minus of 40, 50. Okay. Suppose an object or a car moving along the x-axis from the origin to point P in 5 seconds. So in 5 seconds it moved from O to P. Now if the car turned from P and returned back to point Q after 2 seconds, so from O to P it is 5 seconds, then he returned back from P to Q in 2 seconds. Okay. Now the total path length means the total distance traveled by the car is here is simply total distance is simply OP plus PQ. So OP is equal to 50, PQ is equal to, so PQ is equal to 50 minus 30 or 30 minus, it is simply 50 minus 30, 20. So it is total 70. Suppose it is in meter. So suppose it is in meter, so 70 meter. Now the same object, so rather than considering car, since we have considered a very small distance, so we consider an object. Okay. Now this is 70 meter. So the path length is the total distance traveled or traverse by an object without considering the fact of direction. So here we have not considered any positive or negative direction, since the total distance traveled by the object is, at first it moved from O to P, then it moved back from P to Q, so we have just put the values and we get a result. So the total distance traversed by an object without considering the fact of direction, then we will say it is the path length. So total path length is, in this example, is 70 meter. Now taking the same example, and we will understand another concept known as displacement. In this case, if you notice, then the object moved from O to P in positive direction, and it returned back from P to Q into negative direction. So here the distance for OP is plus 50, but for PQ it is minus 20, and the displacement, in this case displacement is 30 meter. So for the same example, the path length is 70 meter, but the displacement is 30 meter. From this example, we have clearly understand that for displacement, the concept of direction is very, very important. That means for displacement, not only the magnitude, but direction is also associated with displacement. So displacement is a vector quantity. Displacement is a vector quantity. But when we study about the path length, that no direction was involved in that particular case, so path length was a scalar quantity. So displacement is a vector quantity, but path length is a scalar quantity. I have explained vectors and scalars in my previous videos. I have added a link into the descriptions of all these videos. Please watch them. Now, so the displacement is, actually if you notice carefully, then displacement is nothing but the difference between the initial position, which is 0, and a final position. So displacement is equal to final position minus initial position. So final position minus initial position. So in this, with the help of this formula, we can easily calculate the displacement. Now we have understand The two vital concepts, one is path length, another is displacement. Okay. Now we will understand another concept known as uniform motion. If we describe a motion with the help of position time graph. What is position time graph? That means if we take time along x-axis and position along y-axis, then this is known as Poisson time graph. So position is simply referred by x and time is t. So this is xt graph. Suppose an object at t equal to 0 is at some distance, suppose 40 meter from the origin. Now if the object at any time, suppose 1 second, after 2 seconds, 3 seconds, 4 seconds, 5 seconds, the object position is same at every time, then we will simply get a line parallel to the time axis, and in that case we will say the object is in rest. That means no motion involved with the object. Now, so this kind of motion is known as object is at rest. Now, suppose we put for t equal to 0, x equal to 2, for t equal to 1, so x equal to 0, t equal to 1, x equal to 2, t equal to 2 second, x equal to, so these are 0 second, so t is in second, this is second, okay, and it is in meter, okay. So t equal to 0 second, x equal to 0 meter distance, t equal to 1, it is x equal to 2, t equal to x equal to 4, t equal to 3, x equal to 6, t equal to 4, x equal to 8, t equal to 5, x equal to 10. So if we plot the values, so we get a straight line passing through the origin. That means the object move equal distance with equal time. Such type of motion is known as uniform motion. Uniform motion. So uniform motion is a such type of motion where an object moves equal distance in equal time interval. Okay. Now we have learned the xt graph. Xt graph means the position time graph, where one is x, here t. For in case of rest, object is in rest, and in case of uniform motion, object move in straight line. However, sometimes the object may started not from origin 0, it may started from some initial position, suppose x1, then it will move like this. So this kind of graph may also be possible in case of uniform motion. Now the next question is how we can measure the motion. For measuring the motion, we need to learn another two concepts. One is average speed, another is average velocity. So what is average speed? Average speed is nothing but the total path length traversed by the object total path length traversed by the object divided by total time taken by it. Total time taken. So average speed of an object is the total path length traversed by the object divided by total time taken by the object. So we have already learned about the path lengths. So in our example, the first example, if you remember, then we have considered this is x, this is minus x. So this is the origin O. So the object moved from O to P and then returned to Q. Okay. The total path length was at that time from O to P it is 50, then it returned back to next 20, so 70, and from O to P it is 5 seconds, and from P to Q it takes 2 seconds, so total time is 5 plus 2, so 70 by 7 it is 10. So what should be the unit of average speed? Look here, this is total path length, so it is length, so its unit is meter, and here it is time, so its unit is second. So average speed, the unit of average speed is meter per second, and in this example we get average speed is 10 meter per second. Okay. Now we will understand the average velocity. So if you remember the definition of displacement, then it is the final position minus initial position. Now so let the final position be x2 and initial position be x1. So we can denote this kind of differences by a letter, Greek letter delta x. So x with the position of any generalized position can be expressed by x, so delta x gives the difference or displacement, which is x2 minus x1. Now if we take the time interval, del t is t2 minus t1. So time at position x2 is t2 and t1 be the time at x1. So here if I write x1 initial position, x2 final, t1 initial time at initial position, and t2 is time at final position. So now the average velocity is displacement divided by time interval, which is delta x by delta t. So in numerator it is displacement, so it is its length, so it is units meter, and in denominator it is second, the unit of time is second, so the unit is meter per second. So unit of velocity, average velocity is meter per second. Now we can calculate the average velocity for this example. Here in this example, the displacement delta x is x2 minus x1. So it is simply, we have already calculated the displacement, so it is 30 meter. Okay, this is meter. Okay, now time is from O to P, it is 5 seconds, then P to Q it is 2 seconds, and time is independent of x axis, so independent of x or any coordinate axis, so it is simply 5 plus 2, it is 7 seconds. So the average velocity is simply 30 by 7, which is 4 point. So 4.285 approximately. It is approximately 7.285 meter per second. So if you notice the value of average speed was 10 meter per second. So speed and velocity are two different things. So this average speed of this example was 10 meter per second, but the average velocity here is 4.285 meter per second. But sometimes the average speed and average velocity have the same value. If you notice that if we measure the average speed in this case, so it is simply average speed for OP. For O to P movement, the average speed is simply 50 by 5, it is 10 meter per second. And average velocity for OP, here the displacement is same. If we remember the definition of displacement, the final position is 50, initial position is 0, and the total time taken by is 5. So it is 50 by 5, it is 10 meter per second. So for this motion, the average speed and average velocity have the same value. So when the object is in the same direction, object moving in a straight line in the same direction, in that case the average speed and average velocity have the same value. Although average speed and average velocity have different values, but in general it is found that the average speed is greater than average velocity in most of the cases, and when it is equal, average speed equal to average velocity, under what condition? When object moves in straight line without changing the direction. Now we need to learn another two concepts. One is One is instantaneous speed, another is instantaneous velocity. So these two concepts are very important while studying kinematics. So what is the term instantaneous means? Look, suppose an object moving from point A to point B. Suppose distance between point A and B is suppose 100 meter, and the time taken by the object from moving from this point to this point is suppose 5 seconds. Now the average velocity here is 100 by 5, which is 20 meter per second. So the average velocity gives the average value of velocity. Okay, that means the average velocity of the object to move from this point to this point. But it unable to clarify what should be the velocity of the object. Suppose at point this. Suppose this is a point P. So it is very difficult to get the exact value of velocity at that point. So for this we need to learn the concept of calculus, which I have already discussed in my previous video. If you have not watched that video yet, so watch it. I have added the link into the description. Now also we can understand the concept of instantaneous velocity by considering the example of Newton's apple story. Everyone have heard the story of Newton and the falling of apple. So now suppose the tree have certain height h and from which the apple fall. So it reached to the ground at t second. Okay. So obviously the velocity of the apple at this point and this point are not same. So velocity will be changing when the apple move towards the ground. That means at every point, suppose this is the position x1, this is the position x2, this is the position x3. So at every position, the velocity, the corresponding velocity will be different. So if we want to calculate the average velocity, that value will be, suppose we say that average velocity is v. That value may not be equal to these three value. v1, v2, v3 have different value than the value of average velocity. The Newton's question was how we can measure the velocity suppose at this point. So for this he had developed the idea of instantaneous velocity. Instantaneous velocity means the velocity of that object at that particular instant. So how can we measure it? Since the definition of average velocity can be expressed as delta x by delta t. Okay. So the displacement divided by time interval. If you have watched my lecture on mathematical tools for introductory physics, then you have understand that if we change the value delta t by infinitesimal amount, Infinitesimal means it is smaller than the smallest number you could think of. Now, if we change delta t tends to 0, this delta t is not 0, but the increment is very small. In that case, we put the limit delta t tends to 0, delta x by delta t can be expressed as dx by dx dt. So, this is the expression of instantaneous velocity. Okay. Now, we will understand the concept of instantaneous velocity graphically. Suppose we plot a position time graph. Suppose an object move like this. The position of the object is, this is 0. So time, suppose this is t1, this is t2, this is t3, this is t4, this is t5, this is t6, and similarly x1, x2, x3, x4, x5 and x6. Okay. Now, if we measure the average velocity, it will give nothing but the, suppose I want to measure the average velocity. In this case, suppose I want to measure the average velocity for time interval from 0 to t1, 0 to t6. So the displacement average velocity is equal to t6 by t0. So this is 0. So t6 minus of 0 divided by, sorry. Now the average velocity is, here 0 is the initial position and x5 is the final position. If we draw, this is x5. So x5, according to definition of displacement, x5 minus of 0, final position minus initial position, divided by time interval. Time interval is 0 to t6, so it is the t6. So average velocity can be obtained by using this formula for this graph. But suppose I want to measure the velocity at this point. Suppose the time at this is t. Now, suppose the point at t is, at time t is p1. This condition is similar to a situation like, suppose I want to travel from Tezpur to Guwahati. The distance between Tezpur and Guwahati is 180 km. Okay. Now, if the time required to travel 180 km is 3 hours, this average velocity is 180 divided by 3, which is 60 km per hour. So it is the average velocity. If someone asks me that what should be the velocity of the car at Jagirot, then this value may not justify the velocity of that car at the point Jagirot. So here the similar situation. Now for this, what we should do, we need to reduce the time interval. For average velocity, we have considered the entire time interval. So we will, if for particular position, if we want to measure the velocity at particular position, we will reduce the time interval. Suppose we will reduce the time interval by this, then it will give more close to the velocity value at this, at p1. If we reduce the value furthermore, then it will give more accurate value of velocity or towards p1. Or if we reduce the time interval by a very small amount, which is delta t, or in physics this value is called infinitesimal time interval. That means I have explained infinitesimal concept in my lecture on mathematical tools in introductory physics, where I have already told about that infinitesimal means it is smaller than the smallest number you could think of. So for a infinitesimal time interval, the velocity at this point P1 can be derived. So that velocity is known as instantaneous velocity. Okay. Now we have understood it, the instantaneous velocity graphically. Let's understand instantaneous speed. So instantaneous speed is nothing but the magnitude of instantaneous velocity. So it is instantaneous speed is magnitude of So instantaneous speed is magnitude of instantaneous velocity. Now, if you remember that we have calculated average speed and average velocity. In that case, we have found that the average speed is differ from average velocity under a special condition when the object moves in a straight line and without changing its direction. In that particular case, average speed and average velocity will be equal. But in case of instantaneous speed, its value is always equal to the magnitude of the instantaneous velocity. Why? And what the term magnitude means? Since velocity is a vector quantity, so it has both magnitude, both numerical values as well as some directions. So that numerical value is known as magnitude, and I have also explained the concept of magnitude, direction, all in my lectures, vectors and scalars. I have added the link into the description. Please watch them. Now, what is the reason or why the instantaneous speed and instantaneous velocity have the same magnitude? Because we want to measure the velocity at a limited region, at a limited time interval. In that case, the direction is fixed. Direction at that point is fixed. Therefore, since the direction is fixed, so the value of instantaneous speed and instantaneous velocity have the same value. Okay. Now we have understand these two concepts as well. So let's rewind what we have learned so far. We have learned the motion of an object, how we can describe motion, how we can describe position of an object in this class. We have understand the concept of reference frame and also understand one-dimensional motion or rectilinear motion. What is one-dimensional motion? That is the horizontal, vertical or slant motion. But the important condition is that the object moves always in straight line in one-dimensional motion. Now, also we have understand the concept of path length, displacement, and also learn the concept of average speed and average velocity. We have understand the concept of position time graph, and we have learned how we can represent an object in rest or in motion through drawing position time graph. Besides this, we have also learned the concept of instantaneous speed and instantaneous velocity. At this point, I want to stop this lecture. If you like this lecture, then press the like button. You can share the video, and if you want more this kind of content, then please subscribe the channel. If you have any doubts, then write it down in the comment section, and don't forget to press the bell icon for recent notification. Thank you.